So this is our webinar. Again, I'm really excited to have you all here. I hope this will be an interesting and informative lunch break for you. And we are very, very happy, Marie and me, to share some insights from KION as we now see battery storage evolving. And as was said, we will specifically dive into the interaction between storage and the electricity grid. Before that, allow me to spend a few words on what KION as a company does. In a nutshell, we are project developers. We build battery energy storage systems for the time being exclusively in Germany. We have been in the market from, say, the beginning of the second wave of battery storage installations. We were founded in 2021, so you can say it's not a company with a big legacy, but still for storage standards we have now some considerable track record, I would say. What we do is essentially the entire value chain, starting from the greenfield development of the assets. To be precise, what we do is standalone storage. It's not written in stone; it will ever stay that way. But we are right now exclusively developing large-scale standalone projects. There was a question on the audio.
Yes, but I think it's okay now.
Okay.
Yeah, no problem. It's
Okay, excellent. You can hear me. That's good. So we start in the greenfield development, securing land, securing permission, also of course securing grid connections. We then try and optimize the business case around those assets. We talk to route to market providers. We don't optimize the assets ourselves, so this is with third parties. And then we continue all the way till the asset gets commissioned. And what's now new is that for at least a sizable part of the portfolio, we will also stay in responsibility of the assets. You see it on the bottom right side. KION Energy was acquired by TotalEnergies, the French multi-energy company, beginning of last year. And this now allows us to provide substantial equity to also keep parts of our portfolio that we develop. This is, of course, what all project developers are hoping for and looking for, to keep the precious projects developed in the own portfolio. So to some extent, we will be able to do that, and our ambition is to do that at large scale. What we aim for is developing projects in the gigawatt scale. We've done that in the past with Verbund, Opton, Nova, Pelion. So some of the partnerships, specifically with Verbund and Opton, are still ongoing. Very happy about that. And then also, of course, internally with TotalEnergies. On the map, you can see projects that are already online. You don't need to invest the effort in trying and replicate where the projects in development are on the map of Germany. So they're exemplary. They're not the actual locations, but the actual locations of the projects in operation. They are true. If you move one slide further, we also provide you some reference projects. So this is hopefully informative. You see on the left-hand side projects that we have developed in the past. It's like typical projects for those times, 1 hour duration projects. It's all lithium-ion technology, and what we did in the past was NMC technology. And those projects were all connected on the medium voltage level. You see it in my wallpaper background. This is a project in Schwabmünchen, relatively close to our headquarters in Munich. So these projects had a smaller duration, and this moved then over to not only longer durations of 2 hours, but also to larger projects. So this is now what you see on the right hand side, and of course we know we are far from being alone in this. Projects have grown larger. We have also noticed announcements of even much larger projects in the market. But those projects, those references are projects that are either already commissioned. For instance, the project in Tangermünde is a 2-hour project that is now live. The first one commissioned with Trina Energy in Germany. And the projects that are supposed to come here, we mentioned Dahlem, we mentioned Alfeld. Those are projects where everything is secured, where the construction has started, and where we expect an operation date next year. Yes. So now getting into the actual topic of today's webinar. How prepared are we actually in Germany in constructing the energy or electricity grid of the future? And this is an interesting one, because we have a tendency in Germany to always complain. And if we now see what we have here, this is the Bloomberg Global Grids Index. And you see on the left, it includes essentially the major economies of the world, the G7 plus China and India and I think Brazil, yes. And what we see is, firstly, it's maybe a bit uncomforting that on a scale from 0 to 100%, none of the countries here scores high. Right, so there appears to be tremendous shortcomings in making the electricity grid future-proof. But and this was surprising to us when we saw it. And now with the German discussion of what's not working, of lagging behind in grid extension, of lagging behind in almost any respect, how we modify our electricity supply and our energy supply as a whole. This is apparently not reflected by the comparison of Germany versus other countries, where Germany is leading the way in transforming the grid into renewable and energy transition proof system. So this is, I would say, good news, but of course there's still a long way to go. If we now zoom in, what's behind this number in Germany, degree of fulfillment for the future-proof grid, we see that our system on an international level scores high in terms of how many renewables we are able to connect to the grid. These are record numbers these days. In the last year was the record year for renewable connections, and the trend is ongoing. So we achieved in terms of sheer size and amount of renewables a tremendous job. And also now the grid reinforcement is running. So it appears like the issues of more and more problems and delays in grid development is at least in an international standard still on a comparatively good level. That others have an even harder job to deploy the energy infrastructure needed for the challenges. But and this is the big caveat, and what we want to talk about today, we are nonetheless massively lagging behind in digitalization and energy storage as the two other remaining categories that that this index comes up with. So this is I would say very impressive numbers, and if you looked at these numbers alone, Germany would not be pole positioned, but would be much further behind in the list. What can we do about it, and how does it fit into the picture that we described, right? So we saw the picture. I mentioned how many references we have, how dynamic the sector is developing, and then we see this index, and Bloomberg says it's far not enough happening in terms of digitalization on the one hand, and specifically in terms of energy storage on the other hand. So we try here and fit the pieces together. I mentioned in the introduction, if we move one further, I mentioned the battery tsunami, and this is something that initially the Spiegel magazine came up with, and we saw press releases on more and more gigawatts of grid connections, like now coming to the DSOs and TSOs, and threatening the processes, and taking the grid connections from other competing parties, from renewables, from data centers, from you name it. So there's way too much of battery development, and we don't know what we can do about this. Obviously, the way at least we interpret it when talking about a tsunami, it's of course something that we are afraid of. We tried and illustrate this picture here on the left hand side. This is of course something that we want to avoid. And on the other hand, and this is key, and what we want to send you home with. We see from thinking of this index, we see that we have a tremendous lack of flexibility and storage in the system, and we need just to connect the dots. We need to make sure that on the one hand we get enough storage into the system, and on the other hand that the storage is integrated in the grid properly, so that it is not a threat but an actual protection for the grid. Because in the end of the day, battery storage asset is extremely flexible, and it can do, of course, many things that might be harmful to the grid, but it could also provide extremely valuable services and massively increase security of supply in the system. This, of course, like the picture on the right hand side, is our motivation and our goal to achieve when now connecting many gigawatts of storage to the grid. With that, we would like to enter a discussion with you. I mentioned a few releases on ever-increasing grid connection requests for storage. There's one from early this year from the PV magazine, and they mention a total of 650 requests on the transmission level alone. So every reference I showed you before is on the DSO level, and this is 650 on the TSO level, with 226 gigawatts of power. So this is of course an extremely high number. And the question we have for you, like just to get a feeling of how bullish you in the audience are, is whether you think this is maybe the right number of storage in the next few years, whether this is not enough, like underestimated, or whether this is overestimated. So there's already a nice turnout. Like half of you have voted already. Until which year is the question? So the way we understood is once you have the grid connection request. Of course, we don't know, huh? But let's say something like 2030-ish. This is a reasonable time frame where we say when the assets get online that are like meaningfully asked for at the TSO. So I think we are not through yet. I must admit it's a bit of a rhetoric question, but I think, Marie, what do you think? Can we close it?
Yeah, I think we can close it right now. I think most of the people voted.
Okay, and now? Is it visible? So just to be on the, it is visible. Yes, okay. So what you say in the audience is that we will see massively less than this number. I mean, the question, of course, it's which year, what is behind those requests, and so on and so forth. But it is also our impression, and we are not surprised by this result. It is also our impression that we have a discussion that overestimates what is actually coming, and that might create also a threat in the current regulatory discussion, that this what is coming is seen as something we can't control, and something that is like too much, and there's like an atmosphere of gold digging in the market, where everyone is trying to secure the last remaining grid connections. This is something that is in our point of view not sustainable, and will, from our point of view, also lead to the result that we see considerably less of the projects actually hitting the market than what has been asked for. So this is of course important when looking at how would we dimension the grid of the future. Of course, from a project development perspective, we know that we need to have a lot more of project requests and like initiatives to receive an amount that is far less than what has initially been planned for, but nonetheless, and this is now the content of the next part of this webinar. We must still make sure, even if it's a much lower number than the 200-ish gigawatts, to include this in the system in a meaningful way. With this, I would like to hand over to Marie, who will sensibilize you for the key issues and some potential remedies that we suggest.
Thank you very much, Benedikt. Well, as you just mentioned, I will take a step back from it and think about how these battery storages, which will be included in the German energy system, make money, because of course you have to consider how they behave and in which markets they are active. Maybe to begin with, I do think that this is not news to you. Pretty much every business case for battery is rooted in revenue stacking, which means that the batteries will be active in different markets, maybe throughout one day or even in parallel. And that's what makes them so, what makes them able to react on the different market opportunities and maybe needs within just a short amount of time. In Germany, today's business case is mostly rooted in balancing services and energy arbitrage, where balancing services are services provided directly to the TSO, the transmission system operator, which are there to stabilize the grid's frequency. Storage is actually able to assume all types of balancing services, but the most prominent ones for the moment are, of course, the FCR and the AFRR capacity and energy. And I would say that storage is particularly well suited from a technological point of view to be active in these types of markets, because it's just able to react within fractions of a second to the grid's needs at this point. The second pillar of the storage's business case in Germany is energy arbitrage, and it's becoming more and more important. Energy arbitrage is rooted into the price fluctuations on the different wholesale markets, mainly the day-ahead market and the intraday market, which means that the battery will charge when there is a surplus of electrical energy, and it will discharge when there's not enough energy in our system. This then enables us to stabilize not only the energy price, but of course, in the end, the battery is going to be able to make money out of it. Maybe to take a look in the future, there's plenty of discussion in Germany going on about emerging markets where batteries will of course also be able to participate. We're talking about the introduction of inertia and maybe reactive power, where storage will probably be active in the future, and hence help even more to stabilize our energy system. To continue and maybe to come back to our webinar's topic, what I would like to do now is to see how the behavior from a battery storage in the energy arbitrage reflects on our grid in Germany. To do so, I brought along a day-ahead price curve from the week beginning of April. If you can remember, it was quite a sunny week, so we see these peaks going downward in times of high solar radiation, and the battery will act on these price signals. So as I mentioned beforehand, if I place a battery, let's put it in the south of Germany, it will charge at times where the energy prices are low, and discharge in time where the prices are high. So in these times of low prices, what is quite likely to happen, I mean, everything I'm going to say right now is just purely exemplary, so I would really appreciate if you don't take it with a grain of salt. It's only going to be an example on how the market mechanisms work. But let's put this battery in the south of Germany, see the low prices. Low prices are most commonly due to high solar radiation and hence PV power production. This battery will charge, and the grid or the price-based behavior of our battery will be in line with the physical reality, because it will withdraw the energy which was produced from the nearby solar plants. In times of discharging, the battery is going to be nearby these solar plants, which are quite likely to not produce any energy, but maybe some of the wind farms in the north of Germany will still be active, and hence we still have this alignment between the market or price-based behavior of our storage with the physical transport capabilities of our energy network. But the thing is, it was only a coincidence that I placed this battery in the south of Germany and not in the north of Germany. Obviously, our dispatch schedule of the battery is based purely on a price basis. Hence, a battery that will be in the north of Germany will not behave any different than the one in the south. And if we take the same situation as I did just before, the battery would still discharge in a moment where the wind farms in northern Germany are active and the energy is needed in the southwest of Germany. And in this moment, what could happen is that there is a disconnect between the market or price-based behavior of our battery and the physical reality of our electrical grid, because the transport capacities from north to south are just not just not enough to transport all these the energy down south. This behavior is, of course, only a situational disconnect and not a permanent one for a battery placed in the north of Germany, but still needs to be handled with care. And what we see there in itself is something which comes down to how our energy system is set up. So it's not something which is purely based in our storage technology, but from a systemic point of view, you have this price signal, which is nothing else than an indicator if there's too much or not enough energy. And you have these physical limitation of the physical dispatch, which are just not taken into consideration from our price signal. As these mechanisms are applicable to all types of assets, what we have established is the redispatch mechanism. That's where the TSOs and sometimes also the DSOs take measures to rebalance the dispatch schedule of the different assets and the physical limitations of our transmission and distribution network. The problem here comes in because these redispatch mechanisms are just not able to include battery storage at the moment properly. There are, I would say, two obstacles that hinder the implementation of redispatch mechanisms for storage in Germany. The first one would be that just due to the lack of digitalization that Benedikt mentioned in the beginning, from a procedural point of view, we're just not able to include these types of assets. But the most important one is that in Germany, we do have a cost-based redispatch mechanism, and it is quite challenging to determine the right cost compensation for batteries within the redispatch. Hence, they are just not included in the end. The solution we do see discussed quite a lot these days for this problem is to introduce either static FCAs or feed-in restrictions for our battery storages. And at least to me, it appears to be a little odd that we are trying to solve a dynamic problem such as the congestion management with a static solution. This can just not be the most efficient way to solve a problem. Hence, as Kion, what we would like to suggest is to build on these pre-existing dynamic redispatch procedures and include our batteries into it. First, by setting a price-based redispatch structure for the storage asset, which would be an easy fix to include it in the pre-existing mechanisms. And also, and that's where what we call the Kion Speichernav would be to introduce a system where the TSO is allowed to curtail our battery down to zero for no costs for a limited number of hours, which would enable the grid to have some relief for no costs. But still, as this number of hours is limited and the number of hours would be defined on a project-to-project basis, this would still be a win-win situation for both the market and the grid. Naturally, that's going to be a solution which will need to be discussed and will not be applicable to all types of location in our energy grid, because at some point the energy grid are just too congested throughout the year, which will not be suitable for this type of procedure. And that's where I'm going to hand over back to Benedikt, who will conclude this presentation.
Thanks a lot, Marie. So, what does it mean? If we go on the next slide, yes. So Marie now pitched our Speichernav. Like the translation would be the storage grid connection ordinance. So what we did, and you can find it online, is to make a draft for what could be an ordinance or what could be a ruling from the grid agency, to stipulate how storage may in a smart way interact with the grid. So this one is actually from 2023. This is old, and we must really pay attention in Germany. This brings us again back to what Bloomberg found, to speed up in digitalization. We see now, and this is something that is like very, very important for us to message to you in this webinar. We see grid operators coming up with those flexible connection agreements, those FCAs. We have seen a change in legislature in the Energy Industry Act that allows grid operators to do this, and we now have the feeling that this, in the face of this battery storage tsunami, is converted into something where grid operators maybe overdo it to a certain extent in stipulating constraints, static constraints in operating the assets. This is something that will, and this is something that we see in day-to-day project development business, will hinder storage expansion that is so desperately needed, and it is also needed because we think once it's done in a smart way, and we are able to use those assets for the grid, even in the absence of proper price signals. So this is a completely separate story if you want to introduce price zones in the country and get a better match between the locational price and the dispatch. So this is a different story. We as a country have for the time being politically decided to not do this. But still, with the smart regime, redispatch 2.0 has been introduced for all assets beyond 100 kilowatt of power. Batteries are included, and every storage asset is included. The concept is here, but we have lagged behind now for a few years in introducing it, and this is something where really we need to push for, to not forget what the target is, and not take this issue and burden storage with more static restrictions that are only for the reason very static, that a more dynamic and more complex, but also more tailored solution for the assets is not implementable in the current grid structure. This is something that won't allow us to successfully execute this in the next few decades. This is really our key message. In case if there's project developers in the audience, and you get those agreements, there's some better and some worse as we have seen it. But if they are overly static, you should definitely push them back and tell them really to invest more thoughts in making the processes more suitable for a dynamic way of interacting with storage, because obviously the technology, the entire processes is there from the sector to do this. So this is the first and most important point, and then we come to the second point. This is what we call the level playing field in major regulations. It's very important to us that we don't claim subsidies. What KION does is a subsidy-free business, but on the other hand, of course, we don't want to enter a situation where the major competitors in terms of flexibility might benefit from a different regime. This is the idea of the level playing field. I make a specific example. Now, as government wants to build or wants to enact a capacity market to build more gas-fired power plants. Those gas-fired power plants will not pay grid fees. They won't pay the Baukostenzuschuss BKZ levy. They can use the flexibility as they want, and in addition, they receive the subsidy from the capacity market. But this is a different story. It is very important for us then to say, well, if this is the case, storage must not pay the grid fees and the BKZ either. We have come quite a good way in Germany to establish this level playing field in other domains. We are further advanced in other European markets in that respect, and this is also part of the reason it's running quite well in Germany these days. But we have an exemption for grid tariffs that is expiring in 2029. So if assets get connected past 2029, they won't receive this exemption. This is something we must overcome, of course. Otherwise, this won't work. Otherwise, we won't have the level playing field anymore, and otherwise we won't have a battery tsunami. We won't have a battery like flood protection wall, but we will not have any significant storage additions after 2029 at all. So that's the second point. And last but not least, let me also stress, we are talking a lot these days about bureaucracy and facilitating processes for new constructions in general, not only specific to storage or energy infrastructure, but in general. By contrast, what we have experienced in the past 2 years, the situation unfortunately has become worse. We have been able in the past to access some stipulations in the law, the so-called privilege in outer areas in the country, like being allowed to say just file a building permission request on the outside the city limits. This is something that is increasingly difficult, probably as more projects come and the municipalities are afraid of it. But we must again learn to get more hands-on in this respect, to be to allow storage projects a leaner and faster permitting process, so that we will be fast, of course, for the project wave before 2029, before the expiry of the temporary grid tariff exemption. This is very important, but also in the future, of course, it's simply a matter of economics and efficiency to keep the permitting process short and fast, so that we will in the end receive an efficient amount of storage. Coming back to the question we posed you, the efficient amount of storage might be less than 220 gigawatts, but it is certainly way more than what we have now in the system. Certainly a few dozen gigawatts that we will see in the next few years. With that, I would like to thank you for your attention.